So for this set of notes, you're going to need 3 pieces of information. You're going to need this set of atomic compound notes. This is a yellow sheet that you should be getting today. You also will need your periodic table of elements that you've been using, and you're going to get a new periodic table today called the periodic table of ions. This is a darker goldenrod sheet. So you'll need all 3 of those, so make sure you have those before we go. All right, so today we have a question that we are looking at. So far we've been learning all about atoms. We know how to draw atoms. We know what's inside an atom, and we know that the electrons are the things that do the stuff that makes atoms combine. But we want to understand more about how atoms combine today. So we're going to focus on 2 basic ways that atoms combine, and then you're going to learn a little bit about how to work on naming those compounds. So to start out with, we're just going to review how to draw a Lewis dot diagram. We want to draw a Lewis dot diagram for neon, for argon, and for krypton. And so we're going to start by looking at neon on the periodic table. You can see here that neon is right here. It has an atomic number of 10. It has a mass number of 20. And so when we think about Lewis dot, remember it's the outer electrons that we're interested in this case. And so we know that there are 2 electrons on the first energy level. That leaves 8 for the outer energy level. And so I'm just going to draw those around like so. If you don't remember how to draw Lewis dot diagrams, there will be a link on the wiki that you can use to help you learn that. So that's neon. Let's do argon. Okay, so argon is right here. It has an atomic number of 18. That means it has 18 protons, 18 electrons if it's a neutral atom. 2 on the first, 8 on the second. That leaves us with 18 because we have 18 minus 2 minus 10 gives us 8. And so, oh, look at that. This one also has 8 electrons on the outside. And then as a reminder, here's krypton. Well, krypton, if we see the pattern, neon has 8 in its outer energy level. Argon has 8 in its outer energy level. Krypton also has 8 in its outer energy level. And that is because if we look on the periodic table, these things are in the last group, group 18, and we have a special name for those. If you remember, we called those the noble gases. And what makes them noble gases is they do have outer energy levels that are full. And so all other atoms in the periodic table have between 1 and 7 electrons in their outer energy level. So as you can see, these 3 atoms are very stable. They have full outer energy levels. And so how many electrons do atoms want? Well, they want 8 electrons in order to be stable. I think we learned this already, but this is called the octet rule. And the octet rule is something that chemists use to think about how many electrons atoms really like to be stable. So we also have already defined this. This is a review that an ion is an atom that has gained or lost an electron, 1 or more electrons. So an ion has an electric charge. Now we've already learned that this can be a positive charge or a negative charge. In this case, these are 2 new words, however. A cation is an ion that has a positive charge. In other words, it has more protons than electrons. An anion is something that has a negative charge, or more electrons than protons, more negatives than positives. So in the example of NaCl, if we look at our periodic table, we can remember that NaCl, here's Na way over here on the side. Na is in group number 1. Cl is over here in group 17. And we can draw a Lewis dot structure for NaCl. NaCl, its name is, we're gonna see here, let me straighten that out, is sodium chloride. You probably knew that one. That's a very common compound. And another word for that, a more common word, is table salt. So sodium chloride, if we were going to draw a Lewis dot structure for sodium and a Lewis dot structure for chloride, what that would look like is Na. Well, Na has, as we can tell, an 11 as an atomic number. 11 means that it has 11 protons. And if it was a neutral atom, it would have 11 electrons. Well, we know that 11 minus 2 minus 8 is going to leave us with only one electron. And so Na has a single electron on its outer energy level. We can do the same thing with chloride. If you look up chloride on the periodic table, you'll find that it has an atomic number of 17. 17 minus 2 minus 8, well, that leaves us with 7. Remember, this is the electrons on the first energy level, electrons on the second energy level. So we have 7 electrons on the outer energy level here, and so that's going to be like this. We're going to start by putting 1 on either side, go around. And so what you see there is we have, I'll zoom in here a little bit for you, is that chlorine right here has this open spot for an electron, and Na has this extra electron. And so what happens in this case is this extra electron is very unstable, and this really needs an electron to be more stable. And so when Na gives its electron away, it's going to give its electron, we can make that an X and show that that electron now is over here with chlorine. And so what the result is that Na is now a Na plus, because it has one more proton than electron, lost an electron in other words. Cl has an extra electron, so it's Cl minus. And those two things have opposite charges. And so when they come close together, they're going to be attracted to each other, okay? And they will form, Na plus Cl minus will form NaCl. And NaCl is the compound sodium chloride. Now, why is it sodium chloride? Well, we'll learn that in a few minutes. So let's take a look at the patterns we can see then. So if we see that sodium was over here in group 1, it had a charge of +1. We can look in all of the first group of the periodic table, and what we'll find is that all of these will want to give away an electron. And so that's what we call an oxidation number. So that first group is going to have an oxidation number. If we look at the periodic table on your note sheet here, the first group is going to have an oxidation number of +1. Well, we can look at this other side. So we've already defined this last group as has no charge. It's not going to take any electrons or give any electrons, because these are the noble gases we just learned. Let me just write that here. Noble gases. And those are full. Their octet is full. They have 8, and they cannot take any more, and they don't want to give any away because they're stable. So they have an oxidation number, what we call an oxidation number of 0. Well, Cl, where was Cl? Here's Cl here. Cl was in group number 17. If we drew more Lewis dot structures for fluorine, chlorine, bromine, iodine, and down that group, you would find that they all have a opening or a 7 in their outer energy level. And that means that they would like one more to become an octet. And when they get that extra electron, that gives them a charge of 1 minus. Well, you might start to notice that there's a pattern going on here. And you can take a look and see, if you drew some calciums, that they have a 2+. They're in group 2. Then if you looked at oxygen, sulfur, selenium, these have a charge of 2-. They have what we call an oxidation number of 2 minus. We can go this way. We're going to skip these middle ones for a second. We're going to come over here. These have a charge of 3 plus. These have a charge of 3 minus. And then finally we have 4 plus or 4 minus. We'll just leave it as 4 plus for now. So what you might notice here is if you were to fold your periodic table in half, these would sort of touch each other. So 1 and 1 would touch, 2 and 2 would touch, 3 and 3, and then 4. So these oxidation numbers here help us to understand what kind of ion will these atoms become when they gain or lose electrons. Now what's going on in this middle part? Well, I'm just going to write that it's hard to know in this section, and you'll see in a few minutes what's going on in that sort of transition metal area. So let's take another look at an example here. We're going to do one more example looking at oxidation numbers. So let's do the example of, well, let's do an example with charges of 2 minus and 2 plus. So let's go ahead and look at calcium. So calcium, if I were to do a Lewis dot structure of calcium, it would have, let me put that back up here so you can see, it has an atomic number of 20, and so calcium is going to have, let's see, 20. So calcium is going to be 20 minus 2 minus 8, and minus 8 again will leave us with, well, that's 16, 18, it'll leave us with 2. So calcium is going to have 2 electrons, 2 free electrons, or sort of electrons on the outer energy level that are not in an octet. And then let's go ahead and look at, let's do chlorine. So chlorine is still the one we've seen before. Chlorine has an empty spot. Well, I'm changing my mind. Let's look at a new one, which we're going to call CO3. And CO3 2 minus is an ion. This is actually called it's called a poly for many, atomic for many atoms, ion. Because it has many atoms, but it is an ion because the whole thing acts like one. It's got a charge. So I can rewrite calcium as Ca2 plus, because now if it gives those electrons away, it's going to become calcium 2 plus. Carbonate is the name of this, carbonate, and then we can find that in a second. It's a polyatomic ion. It has a charge of 2 minus. Well, what do you suppose those things want to do? They want to come together and form CaCO3, which is calcium carbonate. All right, well, we're still going to go into that a little bit more in a second. Let's take a second to stop, and we'll go on to the next page in the next video.